Assalamualaikum warahmatullahi wabarakatuh and good day everyone. Let's continue our discussion on limits and continuity of function. So here, the first topic here is the infinite limits. We have the definition here. Let f be a function which is defined at every number in some open interval I containing a, except possibly at the number a itself. We say that f of x increases without bound as x approaches a, and it can be written as the limit of f of x as x approaches a is equal to positive infinity. If for every positive number k, there exists a delta greater than 0 such that f of x is greater than k whenever the absolute value of x minus a is between 0 to delta. So, dito sa infinite limits class, ang makikita natin dito or ang mau-obtain natin na result ng limit natin is it's either a positive infinity or a negative infinity. Doon kasi sa previous lesson is ang every time na right after tayong mag-evaluate ng limits, right after natin i-evaluate na yung limit ng function natin is may makukuha tayong constant na function or what I mean is constant na value, di ba? So dito sa infinite limits class, ang makikita ninyo na result ng limit ninyo sa pag-evaluate is it's either positive or negative infinity. Okay, dito sa first definition sa infinite limits, we say that f of x increases without bound as x approaches a. Kung increases siya, ibig sabihin nun positive infinity yung limit ng function natin na f of x. In the second definition, let f be a function which is defined at every number in some open interval I containing a, except possibly at the number a itself. We say that f of x, or the function f of x, decreases without bound as x approaches a, and it can be written as the limit of f of x as x approaches to a is equal to the negative infinity. If it is decreases without bound, yung function natin class, then the limit of our function f of x is equal to the negative infinity. If for every positive number k, there exists a delta greater than 0 such that f of x greater than k whenever the absolute value of x minus a is between 0 to delta. So, ang tatandaan lang natin dito sa infinite limits is if the function increases without bound as x approaches a, ibig sabihin yung limit ng function natin is equal to positive infinity. If the function decreases without bound naman as x approaches a, and then the limit of the given function f of x is equal to negative infinity. We have a theorem here, a following theorem on the two definitions. If r is a positive integer, then limit of 1 over x to the power of r, take note, r is positive integer lang siya. Hindi considered yung negative na integer. As x approaches a to the right is equal to positive infinity. Okay. Limit of 1 over x to the r, take note of this function, 1 over x to the power of r, where r is any positive integer, as x approaches a to the right is equal to positive infinity. Sa letter b naman, this is letter b ha. Okay, this is letter b. The limit of 1 over x to the r, parehas sila ng given na function, 1 over x to the power of r pa rin, where r is a positive integer, as x approaches a to the left, from the left of a, okay, kanina, approaches to the right. So, sa letter B, approaches from the left. So, ang limit daw nito class, pag ganito yung nakita ninyo na function is, pag it is approaches from the left, negative infinity if yung r natin is an odd number. Ibig sabihin, yung exponent ng variable na x natin dito is an odd number. If ever naman na yung r natin is positive, is an even number rather, then the limit of this function is positive infinity. Okay, so let's summarize sa yung theorem natin na 6.4.3. Sa first, or sa letter A, if yung given natin na function is 1 over x to the power of r, where r is a positive integer, then it is approaches a to the right, then the limit is equal to positive infinity. So, mag-follow siya, positive, positive. Sa letter B naman, if the limit of the function 1 over x to the power of r as x approaches a from the left, kung it is approaches from the left, ibig sabihin nun, titingnan natin yung exponent natin. If it is odd, then the limit of this function is negative. Then if it is an even, the exponent of the variable x is, ano yung tawag dito, is an even number, then the limit of this is positive infinity. So let's give an example to illustrate the given theorem. Evaluate the following limits. Okay, sa letter A, limit of 1 over x to the power of 6 as x approaches 0 to the right. Okay, so since 0 to the right, ang always na limit niyan is always positive infinity according to the theorem 6.4.3. This is not 6.4.4, this is 6.4.3. Basta may lenyo saya, hagi function 1 sa puro, tapos sa timan na variable sa baba, na ilan yung exponent yan. Tapos, kung positive infinities kay approaches to the right kanyan, na always din automatica limitan na positive infinity. Okay. Another example is the limit of 1 over x to the power of 5 as x approaches 0 to the right. So, 0 to the right man, automatic na positive infinity. Sa letter C na example, limit of 1 over x to the power of 13 as x approaches 0 from the left. Okay, since from the left siya, titingnan natin yung r natin. So, since ang r natin is 13, that is an odd number, which means kung odd number according to the theorem 6.4.3, number letter B, if yung r natin is an odd number, the limit of the given function is negative infinity. Okay, sa letter D naman, i-differentiate natin yung C and D. Okay, sa letter D at parehas sila na approaches from the left, pero dito tayo magbe-base sa r natin or sa exponent. Since ang exponent natin dito class sa letter D is 8, that is an even number, which means using the theorem 6.4.3, pag even number yung exponent tapos approaches from the left, the limit is automatic na positive infinity. Another theorem is if A is a real number and if the limit of g of x as x approaches to a is equal to 0, take note of this, the limit of the function g of x as x approaches to a is 0, always yan 0 ha. Okay, and the limit of the function f of x as x approaches to a is c, or a constant c, not equal to 0. Okay, ibig sabihin nun dito class sa theorem na to is yung makukuha daw natin na limit ni g of x or yung pangalawang function is equal to 0 daw yan dapat. And then yung limit daw ng f of x natin or the first function as x approaches a is equal to the constant c, where c is a constant not equal to 0. Okay, so we have 4 cases in this theorem. So sa first case, if yung makuha natin na constant or yung limit ng f of x natin is 1, kasi yung c na yan is galing yan doon sa limit ng f of x natin or the first function. If c is greater than 0, which means if positive daw yung nakuha natin na limit ni first function natin is if g of x approaches to 0 through positive values of g of x, if yung makuha daw natin, let's say, what do you call this one? Let's say, maglilet tayo ng values ng x, tapos yung makuha natin na value niya is approaches through positive values ng g of x natin, which means ang limit ni f of x divided by g of x as x approaches a is positive infinity. Okay, yan yung sa case 1. Tandaan lang, c is greater than 0 and then g of x approaches to 0 through positive values. Okay, sa case 2 naman, parehas sila sa case 1. If c is greater than 0 or positive yung makuha natin na limit ni f of x, and then g of x approaches 0 through negative values. So dito sila magkaiba. Then the limit of f of x divided by g of x as x approaches a is negative infinity. Okay, tandaan natin sa 1 and 2, lahat ng C nila is positive or yung constant C is positive, pero yung sa case 1 yung g of x natin is through positive values siya nag-approach, and then yung limit niya is positive infinity. Sa number 2 naman na case, or case 2, if c is greater than 0 and if g of x approaches 0 through negative values of g of x, then the limit of this is equal to negative infinity. Okay. Sa number 3 and number 4 naman na cases, this is less than 0 class. Okay. If c is less than 0 and if g of x approaches 0 through positive values of g of x, then the limit of f of x over g of x as x approaches a is negative infinity. Okay, the opposite. Okay, eto positive, positive. Kapag c is greater than 0 ha, negative, negative din yung sagot dito. Dito sa case 3, less than 0 man daw. Okay, tandaan nyo lang, if makita ninyong negative yung nakuha ninyo na limit ni f of x, tapos through positive values yung g of x, so yung opposite niya. Okay, so negative infinity. Sa case 4 naman, this is less than 0 class. And if g of x approaches 0 through negative values, then the opposite of negative is the positive infinity. Okay, so let's give an example. Evaluate the following limits. Sa letter A, limit of 3x plus 1 divided by x squared minus 2x as x approaches 2 to the right. Okay, so dito sa infinite limits, apply natin dito yung one-sided limit. So ito is a right-hand limit ito kasi positive man, which means approaches to the right of 2. Okay, so here is the solution of the letter A. Okay, si numerator class, we let this one as our f of x, and then si denominator naman is, we let this one as our g of x. Okay, let f of x is equal to 3x plus 1 galing sa numerator natin, and then g of x is equal to x squared minus 2x from the denominator of the given function. Then, the limit of this function f of x as x approaches 2 to the right is equal to the limit of 3x plus 1 as x approaches to 2 to the right is equal to 7. So, saan kinuha si 7? We substitute 2 here. So, magiging 3 times 2, that is 6 plus 1, which is equal to 7. Where 7 is a positive number, which means greater than 0. So, it implies na ang c natin dito is greater than 0. Okay, so it's either nasa case 1 siya or sa case 2 kasi greater than 0 man yung c natin. Okay, and then, limit of g of x as x approaches 2 to the right is equal to the limit of x squared minus 2x. Okay, so ang limit nito, if we substitute 2 here, so magiging 2 squared is 4, minus 2 times 2 is 4. So 4 minus 4, that is equal to 0. So mamimili tayo kay case 1 or case 2. Malalaman natin class is either case 1 ba siya or case 2, case 3 or case 4 if ma-determine na natin or ma-evaluate na natin yung limit ng function natin na f of x. If c is greater than 0, it's either case 1 or case 2. If c is less than 0 naman, which means negative yung nakuha natin dito na result ni limit ng function natin na f of x, it's either case 3 or case 4 naman. Okay, note that g of x greater than 0 for every x greater than 2. Okay, paano natin nasabi yun? Okay, saan galing si x greater than 2? Si x greater than 2 class, doon yan galing kay x approaches 2 to the right. Pag positive, ang corresponding symbol niya is, or inequality is, the greater than symbol. Okay? Pag positive. Kung negative yan class, which means x is less than 2. So, dito kayo magbe-base. Dito kayo kukuha ng number na isa-substitute ninyo kay function na g of x para masabi natin na it is approaches ba through positive values or approaches through negative values. So, let's say for example, x is greater than 2. Yung mga numbers na greater than 2 is Example 3. So 3, when we substitute 3 to the function g of x, di ba ang makukuha natin is 3 squared is 9 minus 3 squared minus 9. 3 squared is 9 minus 2 times 3 is 6. So 9 minus 6, that is equal to 3, which is greater than 0. So kung greater than ito class, which means this one, thus g of x approaches 0 through positive values of g of x. Okay, kasi di ba greater than man siya kung true statement yung g of x sa pag-substitute ninyo right after kayong kumuha ng number dito sa interval na yan, ibig sabihin nun, doon siya nag-approach. Okay, by theorem 6.4.5, number 1 or case 1, ano yung limit sa case 1? We have the limit of 3x plus 1 over x squared minus 2x as x approaches 2 to the right is equal to positive infinity. So, tingnan ninyo doon sa theorem natin sa case 1, ang limit niya if c is greater than 0 and then g of x approaches through positive values is equal to positive infinity. Okay, sa example letter B, this is letter B ha. Okay, this is the example in letter B. Limit of negative 5x over 1 minus x as x approaches 1 to the left from the left. Okay, so take note, this is approaches 1 from the left. Okay, so we let our numerator as the function f of x, eto siya, and we let our denominator as the function g of x. Always yan class, sa numerator si f of x, si g of x naman is yung nasa denominator. And then after that, we get the limit of the function f of x. So the limit of this is magiging limit of negative 5x as x approaches 1. So na-mention ko na doon sa previous video natin na if one-sided limit yung given natin na function class is sa pag-substitute, you do not need to include the sign or the sign here in the exponent of the a. Okay. So, ibig sabihin yung number lang nyo is a substitute natin dito. So, we have negative 5. Replace x by 1. So, we have negative 5 times 1 is negative 5. So, which means, since negative yan class, our c here is less than 0. So, take note. Okay. Pag greater than, ang corresponding sign niya is positive. Pag less than naman, ang corresponding sign is negative. Okay, so since less than 0 si C, it's either case 3 or case 4. Okay, sa case 3 or case 4 class, depende kung ano yung makuha natin na or saan nag-approach yung g of x natin. And then the limit of g of x as x approaches 1 from the left is equal to the limit of 1 minus x. So, replace x by 1. So, that is equal to 0. So, take note, yung g of x natin class, yung limit niya, that is always equal to 0 to apply the theorem 6.4.5. Okay. Now, g of x is greater than 0 for every x is less than 1. Bakit ito less than 1? Kanina sa previous example, greater than 2, no? Less than 1 class kasi galing siya dito. Yung x, yung limit natin is approaches from 1, from the left of 1. Approaches 1, from x approaches 1 from the left. Okay. Less than 1. For example, yung mga numbers na less than 1 is 0.9, diba? Or pwede ding 0.5, pwede ding 0. So, kung ang makuha natin na number or sa pag-substitute natin kay g of x is greater than 0, which means that is approaches through positive values. Kung less than naman ito class, which means it is approaches through negative values. So, example, ito, yung pinili natin na value ni x na less than 1 is 0.9. So, i-substitute natin kay function na g of x. Okay, eto. So, ang function na g of x is 1 minus x. So, magiging 1 minus 0.9 is 0.1. 0.1 which is greater than 0. So, since greater than, which means si g of x natin approaches to 0 through positive values of g of x. Kung less than na niya sa 0, which means approaches through negative values. By theorem 6.4.5, number 3, okay, the limit of the given function negative 5x over 1 minus x as x approaches from the left, 1 from the left is equal to negative infinity. Okay. Third example, this is letter C, ha? Okay, for the third example, the given limit is negative 2 square root of 5 minus x divided by x cubed as x approaches 0 from the left. Okay, 0 from the left. So we let our f of x as negative 2 square root of 5 minus x and g of x is equal to x cubed. Okay, then right after ninyong ilet, si f of x and g of x, get the limit of both function. So, limit of this is magiging negative 2 square root of 5 minus 0 kasi 0 yung a natin. So, negative 2 square root of 5 minus 0 is negative 2 square root of 5 which is less than 0 kasi negative man. So, madali lang tandaan kung negative, c is less than 0. Kung positive naman, c is greater than 0. And the limit of g of x is automatic yan na 0. So, since g of x is less than 0, okay, paano natin nasabi na less than 0 siya? For every x is less than, this is not x less than 0, 1. This is 0 class. Okay, this is x is less than 0. Okay. For every x is less than 0, kasi nag-approach man yung x natin is 0 from the left. So, replace it by 0. Okay, correction ha. For example, ano yung mga numbers na less than 0? So, negative 1. Okay, replace natin to by negative 1. So, ang mga numbers na to the left, from the left of 1 is negative 1, negative 2, negative 3, yung mga negative na numbers. So, if we substitute negative 1 here, we get negative 1, di ba? Kasi negative 1 raised to the power of 3 is negative pa rin. So, this is negative 1. Okay, nagkamali ito. Hindi ko siya na-edit. So, this is less than 0. So, which means negative 1 is less than 0. So, since less than 0 ito class, okay, erase ko lang ha. Okay. Ulitin ko. Replace this one by negative 1. So, negative 1, substitute natin kay g of x. So, magiging negative 1 cube is negative 1 pa rin. So, negative 1 is less than 0. So, kung less than ito, it is approaches through negative values. This is negative values. This is not positive. Through negative values of g of x. By theorem 6.4.5, this is number 4. This is that number 3. We have the limit of the function negative 5x over 1 minus x as x approaches 0 to the left, from the left rather, is equal to, this is positive infinity. Okay, this is positive infinity because yung g of x natin is approaches 0 through negative values. So, since less than 0 man yung c natin, so it satisfies the condition number 4. Less than 0 si c, through negative values din yung g of x natin, so which means the limit of this is positive infinity. For the last example, this is letter D. Okay, limit of x minus 3 over the absolute value of x minus 1 as x approaches 1 from the left. So we let our f of x as x minus 3 and g of x is equal to the absolute value of x minus 1. Then the limit of the function f of x is equal to negative 2. Okay, simply substitute 1 here. So magiging 1 minus 3, that is negative 2, less than 0. So which means c is less than 0. So, it's either case 3 or case 4 kasi less than 0 yung c natin. Then, the limit of the function g of x is equal to 0. Since g of x is greater than 0 for every x is less than 1, eto class, Na-determine natin ito galing dito. So, galing siya kay x approaches 1 from the left. Kung positive yan, which means greater than din yung symbol na gagamitin natin dito. So, ano yung mga numbers na less than 1? For instance, 0, di ba? Kung 0, ang ma-obtain natin when we substitute 0 to the function g of x, so magiging 0 minus 1, negative 1. Since absolute value man, which means we need to consider the positive. So, we can say that g of x is greater than 0. So, thus, g of x approaches 0 through positive values of g of x. By theorem 6.4.5, number 3 or case 3, we have the limit of this is negative infinity. Kasi yung opposite ni positive dito. Okay, so that is for the theorem 6.4.5. The next theorem is 6.4.7. If the limit of f of x as x approaches a is positive infinity and limit of g of x as x approaches a is c. So, baka baligtaran doon sa 6.4.5. Kanina kasi, dun sa 6.4.5, yung limit ng function natin na f of x is equal to the constant c. Then, yung limit ng g of x natin doon is 0. So, dito, class, iba naman. Yung limit ng f of x natin is positive infinity. Then, yung isa, yung limit ng g of x is siya na naman yung magiging constant c. Then, the sum of the function, the limit of the sum of the function f of x plus g of x as x approaches a is positive infinity. Okay, so simple lang yan. Si positive, di ba ang result nito sa pag-evaluate ng limit is positive infinity? Tapos, yung limit ni g of x is c. So, positive infinity plus constant, that is positive infinity, of course, kasi mas malaki yung value ni positive infinity kaysa kay constant c. Kung negative naman, class, sa number 2 na theorem, case 2, kung negative infinity yung limit ni f of x, then yung limit ni g of x is c. So, negative infinity plus the constant c, automatic na negative infinity. Of course, kasi mas malaki yung value ni negative infinity. Okay, remark, sa theorem 6.4.7, take note, is still true if x approaches a is replaced by x approaches a to the right or x approaches a from the left. So let's give an example to illustrate the given. For example, evaluate the following limit. So ang first is limit of negative of 3 over 3 minus x. The negative plus is dito sa gitna nila, plus x over 2 plus x. So, para ma-apply natin si 6.4.7 na theorem, we let this one as our f of x, and this one naman is our g of x. So, using the theorem 6.4.5, yung first class na theorem natin, kasi di ba doon sa 6.4.7 na theorem, kailangan daw yung limit daw ni f of x is it's either positive or negative infinity, di ba? So, para malaman natin na it's either positive or negative infinity ba, kailangan natin i-apply dito si 6.4.5 na theorem. So, which means, kailangan natin yung 6.4.5 na theorem. Okay, dito sa infinite limits. To solve the limit of this. And then, yung sa g of x is direct substitution lang. Okay, so, by theorem 6.4.5 number 2, we have the limit of this, limit of negative 3 over 3 minus s as x approaches 3 from the left is equal to negative infinity. So you can check that one using the theorem 6.4.5 if negative infinity ba talaga siya. So I am sure na that is negative infinity. Now we have the limit of x over 2 plus x as x approaches 3 from the left. Ito yung sa g of x natin. Ito siya. Direct substitution lang. So, if we substitute 3 here, so we have 3 over 2 plus 3 magiging 3 over 5. So, constant yung makukuha natin kay function g of x. So therefore, by theorem 6.4.7 number 2, we have, di ba ang limit nito class, itong sa first function is negative infinity, and then plus, yung limit nito is 3 over 5. So negative infinity plus a constant is always negative infinity. Next example class, limit of 5x over negative 1 minus x minus 4 over 3x as x approaches negative 1 to the right. Okay, so gaya a first function da, no? Na ginanipaglat ta no function f of x. Okay, gaya mo bo second function ta, no? Na ginanipaglat ta no function na g of x. Si function f of x class, para katukawan niyo is either positive or negative infinities kaniyan, na pag-usar niyo saya a theorem sa pag-evaluate saya na, so theorem 6.4.5. Okay, so by theorem 6.4.5, number 4 or case 4, the limit of this function 5x over negative 1 minus x as x approaches negative 1 to the right is positive infinity. So, pwede ninyong i-check if it is positive infinity ba talaga siya. Tingnan ninyo yung sa theorem 6.4.5. Now, the limit of the second function 4 over 3x as x approaches negative 1 to the right is equal to negative 4 over 3. Bakit? Kasi substitute natin si 4, negative 1 dito. So, 4, constant lang yan. So, 4 divided by 3 times negative 1 is 4 divided by negative 3. That is negative 4 over 3. So, by theorem 6.4.7, case 1, it follows that, okay, yung limit nito class, yung first function natin is positive infinity. Then, yung limit ng second function natin is negative 4 over 3. Okay. So, we have positive minus the constant is always positive infinity. Dito sa next theorem na to, sa 6.4.9, the same lang siya doon sa 6.4.7, but the operation here is a multiplication. Kanina kasi doon sa 6.4.7 is sum or the difference of the two function. If limit of f of x as x approaches a is positive infinity, and limit of g of x as x approaches a is c. So, di ba the same lang sila na condition where c is a non-zero real number. If c is greater than 0, which means if positive yung constant natin class, yung limit ni g of x, then the limit of the product of the two function as x approaches a is equal to positive infinity. Kung positive, so siya kakwata, no? Okay, if c is less than 0 naman, then the limit of the function is the limit of the product of the two function is negative infinity. So, simple lang. If positive times positive, di ba? That is equal to positive. Kung negative times positive, that is equal to negative. Rule sa multiplication, like sign positive and like sign negative. Gito bitinudan nyo saya sa 6.4.9. For example, the same pa rin to ng process doon sa 6.4.7, but the operation here is a multiplication. So, which means, yung first function natin, we let this one as our f of x, and then the second function naman is our g of x. Okay, si f of x class, i-evaluate yuwanan using the theorem 6.4.5. So, you can check if this is case 4 ba, tapos positive infinity siya. Okay, and the limit of the g of x, 1 minus x over x plus 3, as x approaches 2 to the left, is equal to negative 1 over 5, because 1 minus 2 is negative 1, then 2 plus 3 is 5. So, it follows that from theorem 6.4.9, this is positive infinity yung result nito, galing dito, and then yung result nito class is negative 1 over 5. So, positive infinity times negative 1 over 5 is negative infinity. Of course, unlike sign is equal to negative. Positive times negative is negative. Another example, limit of 3x over x minus 1 multiplied by 3x plus 1 over x minus 1 half. So, parehas pa rin ng process. Okay? Evaluate this one using the 6.4.5 na theorem. Then, ito naman is the direct substitution lang. So, ito, ang limit daw nito by theorem 6.4.5 number 1 is equal to positive infinity. Pwede ninyong i-check ha if hindi kayo sigurado na yan talaga yung limit niya. Or hindi kayo convincing. And limit of this g of x, 3x plus 1 over x minus 1 half as x approaches 1 is equal to 8. Okay, just simply replace 1 to the variable x. So 3 times 1 is 3 plus 1, 4 over 1 minus 1 half, that is equal to 8. So it follows from 6.4.9 case 1, that is, okay, so we have positive infinity multiplied by positive 8, di ba? So, since positive infinity multiplied by positive 8 na constant, that is positive infinity. Okay, sa theorem 6.4.12, the same lang talaga doon sa 6.4.9. Ang tatandaan nyo lang, class, is yung concept na positive times negative is equal to negative. Tapos, negative times negative is equal to positive. Kasi di ba, if c is greater than 0, positive siya. Then, the limit of this function, class, okay, then yung limit daw ni f of x na negative infinity, so positive times negative is negative. So, yan yung sa case 1 sa 6.4.12. Sa 6.4.12 number 2 naman, less than 0, which means negative cc. Then yung limit ni f of x is negative infinity man. So negative times negative is positive infinity. So actually, pwedeng isahin lang naman si 6.4.9 and si 0.12 na theorem. Basta, ang tatandaan na concept is yung rule sa multiplication, like sign, positive, and like sign is negative. So here are the examples of 6.4.12. Limit of 7 over x cubed times 4x minus 10 over x plus 5 as x approaches 0 from the left. Okay, so parehas pa rin ng process. Evaluate this one using the 6.4.5 and this one naman is by direct substitution lang. So ang limit daw nito, class, is positive, limit of this by theorem 6.4.5 case 2 is negative infinity. So, which means, negative infinity yung sa first function natin. Okay. And then, yung sa second function, if you substitute 0 here, so 4 times 0 is 0 minus 10. So, negative 10 over 5, that is negative 2. So, negative infinity multiplied by negative 2. So, that is positive infinity. Negative times negative is positive. For the last example of this theorem, limit of 5x minus 2 over 2x minus 1 times x over x plus 1 as x approaches 1 half from the left. Okay, so the same process pa rin. Evaluate this one using the theorem 6.4.5. The second function is just the direct substitution. So by theorem 6.4.5 number 2, or case 2, the limit of the function f is negative infinity. And the limit of x over x plus 1 as x approaches 1 half to the right, from the left rather, is 1/3, which means negative infinity multiplied by 1/3. So negative times positive is negative infinity. Okay, so di nyo na kailangang i-memorize yung theorems, basta ang tandaan nyo lang kay 6.4 and 6.12, 6.4.9 and 6.4.12 is positive times positive, positive. Negative times negative, negative. Positive times negative, negative. Negative times positive is negative. Kung ang operation is multiplication. Tapos, always na limit ni f of x is it's either positive or negative infinity. Para malaman ninyo it's either positive or negative infinity, do not forget to use the theorem 6.4.5. Okay, so that's all for the infinite limits. Here, the second topic is the limits at infinity. So, kabaliktaran. Kanina, infinite limits na ayap kakwatan no result o limit tano na it's either positive or negative infinity. Sayap man sa limits at infinity na baliktad man. Okay, so let's see kung ano yung pinagkaibahan ni infinite limits and limits at infinity. Let f be a function which is defined at every number in some open interval a to the positive infinity. The limit of f of x as it increases without bound is L. Okay, it is written as the limit of f of x as x approaches to positive infinity is L. So, dito class, sa limits at infinity na, so x tano na it is approaches or di na so limit tano class. So, limit of function tano na it is approaches, it's either positive or negative infinity. Gitanudan nyo saya ki limits at infinity. May line nyo wala gides kanyan. Si positive or negative infinity na si matatago sa baba limit, a word, or si LIM na which means na limits at infinity yanan. No, may line nyo man, natubag, result yan dapat na it's either positive or negative infinity na infinite limits ito. If for every epsilon greater than 0, there exists a number n greater than 0 such that the absolute value of f of x minus L is less than epsilon whenever x is greater than n. So the symbol, rather, x approaches to the positive infinity is used to denote that x increases without bound. Another definition in the limits at infinity, let f be a function which is defined at every number in some open interval a to the negative infinity. So, hindi ito baliktad ito ha, dapat this is negative infinity to a. Okay. The limit of f of x as x decreases. Okay, kanina, sa previous definition is increases without bound. So, dito, x decreases without bound is L. It can be written as in this form. Limit of f of x as x approaches to negative infinity. So, gate kanudan tano saya sa limits at infinity is the limit of the function f of x is L. If for any epsilon greater than 0, there exists a number n less than 0 such that the absolute value of f of x minus L is less than epsilon whenever x is less than n. So the symbol x approaches to the left is used to denote that x decreases without bound. Okay, so let's give an example. So before that, we have this theorem here. So if r is a positive integer, di ba parehas doon sa infinite limits? Ito yung pinaka first theorem doon. Then, okay, take note, lahat 1 over x to the power of r as x approaches to positive infinity is always equal to 0. So, pag nakita ninyo na x approaches to positive infinity, tapos yung given natin na function is 1 over x to the r, where r is a positive integer, automatic na 0 yung limit niya. And then, the second one is the limit of 1 over x to the power of r as x approaches negative infinity is 0. So, theorem 6.5.3 is still true if x approaches a is replaced by x approaches to positive infinity or x approaches negative infinity. Okay, so before ako magbigay ng example, let's differentiate from the infinite limit. So take note, this one is for limits at infinity. Okay, limits at infinity. Okay, yung sa infinite limits, parehas sila if r is a positive integer, di ba? Okay, the same din ang given na function. Sa infinite limits, okay, sa infinite limits, limit of 1 over x to the power of r as x approaches a to the right, di ba? Okay, kung makikita ninyo, is equal to positive infinity. So, let's compare Eto, yung x natin is approaches a to the right. The same sila ng function, right? Okay, parehas ng function. But here, si positive infinity is dito nalagay kay x sa limits at infinity. Kung a to the right siya, ibig sabihin nun, positive infinity din yung result niya. So, dito, baliktad. Si positive infinity dito nalagay kay x or si negative infinity dito nalagay kay x. So, ang limit dito is automatic na 0. Okay. So, here is the example. Evaluate the following limits. Limit of 3x squared plus 7 over 2x squared minus 5 as x approaches positive infinity. Okay, take note. Pag nakita ninyong x approaches to positive infinity, yung magiging solving ninyo class is using the limits at infinity. Okay, to be able to apply the theorem 6.5.3, we divide both numerator and denominator by the highest power of x. Take note of that. Highest power of x occurring in either the numerator or the denominator, which in this case is x squared. Diba? X squared yung highest exponent or highest power ng x natin dito. Both numerator and denominator. Ibig sabihin nun, class, pag nakita ninyo na x approaches it's either positive or negative infinity, nakakasulba nyo sana, pagilay nyo, okay? Ikadwa, pagilay nyo ron na, ilayan nyo ang pinaka-highest power saan or highest exponent ta x sa may exist both numerator and denominator. And thereafter that, i-compare ninyo. Kung mas malas so exponent sa numerator, dito ipag-divide iyo both numerator and denominator. Okay, so dito, the same lang naman ang degree yung numerator and denominator natin. So, thus, applying the previous theorems and previous 6.5.3, letter A, we have, okay, ito yung given natin. Okay, so since si x squared yung highest power, so i-divide natin yan both numerator and denominator. So we have 3x squared divided by x squared plus 7 divided by x squared divided by all over 2x squared divided by x squared minus 5 divided by x squared. So 3x squared divided by x squared is 3 na lang. This is 3. Okay, wala yan. Okay, plus 7 over x squared over 2x squared divided by x squared is 2 na lang minus 5 over x squared. So, alam natin, okay, so pwedeng i-separate natin kunin yung limit nito. So, we have the limit of 3, kasi diba 3 yung sa first term sa numerator, plus 7 over x squared, divided by the limit of 2 minus 5 over x squared as x approaches to positive infinity. So, ang limit ni 3, constant man yan, so 3 pa rin. So, bakit ito naging 0? Okay, so 7 over x squared plus, okay, bakit naging limit niyan is 0? Kasi diba, applying the theorem 6.5.3, okay, si 7 over x squared, we can rewrite this one as 7 times 1 over x squared, diba? 7 times 1 over x squared is just equal to 7 over x squared. So, sa theorem 6.5.3 na limit kon o 1 over x to the power of r as x approaches to positive infinity na always yan equal to 0. So, that's why ang limit nito is equal to 0 man. So, 7 times 0 is 0 pa rin siya. Okay, the same with the denominator, limit of 2 is 2, negative 5 over x squared, limit niyan is 0. Okay, ganito na lang. Pag nakita ninyong variable x na lang sa denominator tapos may exponent siya na positive tapos sa numerator ninyo is number na lang, automatic na ang limit niyan is 0. So 3 plus 0 is 3, 2 minus 0 is 2. So the limit of this function is equal to 3 halves. Another example, class. Another example, limit of 5x minus 8 divided by the square root of 10x squared plus 3 as x approaches to negative infinity. So, kahit negative pa yan or positive infinity, kung i-apply natin si 6.5.3, always yung limit niya is 0. So, we divide both numerator and denominator by the highest power x occurring in either the numerator or the denominators, which in this case, square root of x squared. Okay, bakit natin nasabi na square root of x squared? Kasi sa numerator, ang degree ng numerator natin is 1. So, tingnan natin sa denominator natin. So, since x squared dito, which means ang degree nito is 2. Okay. So, bakit hindi lang si x squared yung kinuha natin? Since si x squared kasi class is nasa loob man siya ng radicals, which means isasali natin si radical. Okay, so which in this case is square root of x squared. Ibarat muna, highest exponent saya na matatagong mo sa cube, o ibarat muna, cube root of x cube. Nagi yung mabui, in-divide you both numerator and denominator. Ibarat po, saya kasi na x squared of square root of x squared man, which means nagi na ni-in-divide ta no both numerator and denominator. Since x approaches to the from the negative infinity, to negative infinity, or negative values of x are being considered. Okay, ibig sabihin, consider natin dito yung mga negative values of x since it is approaches or the limit of the given function is approaches to negative infinity. So it follows that the square root of x squared is equal to the absolute value of x, which is equal to negative x. Okay, di ba? Apply natin to, maka-cancel out si x, si index, so x na lang. So, sa Math 111 ninyo, meron ito doon. I think sa theorem ata ng mga inequalities, if I'm not mistaken. The equivalent of the square root of x squared is the absolute value of x. Kaya siya naging negative class kasi i-consider natin dito yung mga negative values because it is approaches to negative infinity. Kung if it is approaches to positive infinity, of course, ang i-consider lang natin dito na values is lahat ng positive values of x. Thus, applying the previous theorems and the theorem 6.5.3b, we have, okay, so this is the given function. 5x minus 8 over the square root of 10x squared plus 3 as x approaches to negative infinity. So, ang limit nito, so ang i-divide natin both numerator and denominator is the square root of x. So, 5x divided by the square root of x squared rather, minus 8 over, divided by the square root of x squared all over the square root of 10x squared plus 3. Okay, so 5x, paano to naging paano naging negative x yan? Eto class, dito yan galing. Kasi i-consider natin yung negative na values ng x. So, minus 8, si square root of x squared, naging negative x na dito. Galing siya dito ha. Divided by the square root of 10x squared, pinasok natin dito sa loob or inisang radical na lang natin yung sa denominator natin kasi the same lang naman sila na index. So we have 10x squared over x squared plus 3 over x squared. So 5x divided by x is negative 5. Negative 8, minus 8 over the negative x is positive 8 over x. And then sa denominator naman, we have 10 na lang sa first term. Sa second term is 3 over x squared. So we have negative 5. Ang limit ni negative 5 is negative 5. Limit ni 8 over x is 0 na yan from the theorem 6.5.3. Then square root of 10, limit ni 10 is 10. Limit ni 3 over x squared is 0. So we have negative 5 over the square root of 10, or that is equal to negative 10 square root of 2. Multiplying both numerator and denominator by square root of 10. So we obtain negative 10 square root of 2. So therefore, this is the limit of the function 5x minus 8 over the square root of 10x squared plus 3. Okay, for the last example sa limits at infinity, limit of 2x squared over 3x plus 2 as x approaches to positive infinity. Okay, so first thing to do, Tingnan natin kung saan ba nag-approach yung x, kung positive or negative infinity, which means limits at infinity yan. Then after that, tingnan natin both numerator and denominator. Ano yung, or tingnan natin kung ano yung highest power of x na nag-occur sa either the numerator or the denominator. Then yun yung i-divide natin both. Which in this case, class, is x squared, di ba? Ito yung my highest power of x, nasa numerator siya. Thus, applying the previous theorems and theorem 6.5.3a, we have 2x squared divided by x squared, 3x divided by x squared. Naging x squared yung dinivide dyan, class, ha, kasi siya yung nag-exist dito sa given natin na highest exponent. Okay, yung limit nito is 2 over, limit nito is 3 over, what I mean is, this is equivalent to 2 kasi 2x squared divided by x squared is cancel out na si x squared, that is equal to 1, di ba? Multiplied by 2, that is equal to 2 pa rin. So 3x divided by x squared is 3 over x na lang, plus 2 over x squared. So we have, ato class, is, apply natin dito yung sa denominator ba? Okay. At saka, to evaluate this one, we let f of x is equal to 2, and then g of x is equal to 3 over x plus 2 over x squared. So now, the limit of the function f of x is equal to 2 because 2 is just a constant, right? The limit of the constant is just a constant function. So, by theorem 6.5.3a, ang limit nito, 3 over x. Okay, applying the theorem 6.5 ha, 0.3. Ang limit ni 3 over x is 0. Ang limit ni 2 over x squared is 0. So, that is equal to 0. So, further, g of x greater than 0 for all x greater than 0. We are considering positive values of x because x approaches to positive infinity. Take note, it is approaches to positive infinity. Thus, the g of x approaches through positive 0 through positive values of g of x. Therefore, by theorem 6.4.5, case 1, okay, naging case 1 siya kasi yung limit ng f of x natin is 2 man, which is greater than 0. So, ang limit nito, we have 2 over 3 plus 3 over x plus 2 over x squared is equal to positive infinity. Okay? So, here's the last topic sa limits and continuity of function, the continuity of a function. So, tapos na tayo kay formal definition ng limit, kay theorems on limits, one-sided limits, the infinite limits, and limit at infinity, and the last one is the continuity of function. In the previous section class, we pointed out that if limit of f of x as x approaches to a exists, then its value is not necessarily equal to f of a. The value of the function to the number a, in fact, f of a may be undefined, diba? On the other hand, it is possible for the value f of a to exist and not limit of f of x as x approaches to a. When both exist and equal, we say that the function f is continuous at x is equal to a. So this is stated formally in the following definition. We can say that the function is continuous at the number a if the following three conditions are satisfied. So, the first condition, class, is f of a exists. So, tingnan natin if may mag-exist ba na f of a. So, ang gagawin lang dito sa condition 1, class, kung ano yung given na a, is isa-substitute lang natin doon sa given na function. Kapag define yung nakuha natin, which means nag-exist yung f of a. Sa condition 2 naman, the two-sided limit exists. Pag walang nakalagay dito na plus or minus sa exponent ni a, which means that is a two-sided limit exists. Okay, paano natin masasabi na mag-exist yung two-sided? From the theorem on the one-sided limit, if the right-hand limit and the left-hand limit exist and they are both equal, which means we can say that the two-sided limit exists also, right? Okay, so kailangan natin gamitin yung sa theorem ng one-sided limits. And then the last condition, class, is sa step 1, sa step 2 rather, at saka sa step 1, if equal yung makuha natin sa kanila. If yung result ni step 2 is equal siya sa result ni step 1, we can say that the function is continuous at the number a. So let's give an example to illustrate this given definition. Before we give an example, we have some reminders here. If one or two of these conditions fail to hold, then we say that the function is discontinuous at x is equal to a. So, ibig sabihin lang ng class, if isa or dalawa lang doon sa condition na yun yung mag-fail to hold, ibig sabihin hindi nag-satisfy doon sa tatlong condition na yun, is we can say that the function f is discontinuous at x is equal to a. So, geometrically, a function f is discontinuous at a number a if there is a break or cut in the graph of y is equal to f of x at the point where x is equal to a. So, the discontinuity class is essential discontinuity. Okay, may tinatawag tayong essential discontinuity. If condition 2, okay, take note, if condition 2 fails to hold. If ever na mag-fail to hold yung sa condition 2, we can say that the discontinuity of the function is unessential. Okay, that is the two-sided limit rather does not exist. Also, the discontinuity is removable discontinuity if condition 1 fails to hold. So that is f of a is undefined. So yung removable discontinuity class is bihira lang yan. Ang always na nag-exist is yung essential discontinuity. Kasi, pag nag-fails to hold na yung sa f of a, which means, masasabi na natin na discontinuous yung function natin. Okay? So, condition 2 yung mag-fail to hold, that is an essential discontinuity yung discontinuity natin. If f of a naman, or the condition fails to hold, that is removable discontinuity. So let's give an example. Determine if the given function is continuous at the indicated number a. If it is discontinuous at x is equal to a, determine if the discontinuity or is removable or essential. So for example number 1, or for example letter a, ang given natin na function class is f of x is equal to 2x plus 5 at x is equal to negative 3. Say negative 3 class, yan yung a natin. Okay, so ang function natin class is 2x plus 5. Okay, so para malaman natin if it is continuous or discontinuous, let's apply the three conditions. Okay, sa first condition, thus, f of a exists. Okay, so tingnan natin. Since a is equal to negative 3, eto siya galing dito, we have f of a, replace a by negative 3. So, substitute natin si a dito kay 2x plus 5. So, magiging 2 times the negative 3 plus 5. That is negative 6 plus 5 is negative 1. Hence, f of a is equal to f of negative 3, which is equal to negative 1 does exist. Okay? So, nag-satisfy yung condition 1. Let's proceed to the condition 2. Thus, the two-sided limit exists. Okay? So, madali lang etong first example natin kasi direct substitution lang para malaman natin yung two-sided limit ba is nag-exist. Okay, so just simply substitute. So, limit of f of x. Ito yung definition ng limit natin class ha. Okay, as x approaches a, so simply replace f of x by 2x plus 5 from the given. And then, replace a by negative 3. This is not 33. This is 3. Okay, replace x by 3. Negative 3 rather. So, magiging 2 times the negative 3 plus 5 is negative 1. Thus, the limit of f of x as x approaches a exists. So, tama din yung sa condition 2. Nag-satisfy din siya. So, which means, pag nag-exist yung, nag-satisfy yung condition and condition 2, pwede pa tayong mag-continue kay condition 3. If ever na hindi na nag-exist yung sa condition 2, which means, jump na kayo sa conclusion. Okay, sa condition 3, this is 3. This is not 1. Okay, 3. This is condition 3. This one is condition 2. Is the limit of the f of x as x approaches to a is equal to f of a. From condition 1 and condition 2 class, we can say that the limit of f of x as x approaches a is equal to the f of a. Since we obtained f of a is equal to negative 1, di ba? Yung condition 1 natin, we obtain negative 1. And then sa condition 2, we obtain also negative 1. So they are equal. So therefore, since equal sila, okay, we can say that the function f is continuous at x is equal to 3 kasi nag-satisfy man yung tatlong condition. Okay, so that is for the another example is the function f defined by f of x is equal to 1 plus x, where x is less than or equal to 2. And then the second function is 2 minus x, where x is greater than 2. So at x is equal to 2. So ang a natin dito class is equal to 2. So, giya as a first function class na ipag-consider tayo no sa value sa x na from, wait lang, from negative infinity, okay, kasi less than man, no? So, from negative infinity to positive 2. Okay, close interval siya kay 2. Yung second function naman, kung consider natin dito na values ng x is from positive 2 to positive infinity. Okay, so dito tayo magbe-base. So take note, ang a natin is equal to 2. So sa condition 1, thus f of a exists. So capital letter F yung ginamit kasi capital letter F din yung given natin class ha. Kung g of x yan, of course, g of x din yung ilalagay natin dito. Since a is equal to 2, from here, and the function f that satisfies the given a is equal to 2 is the function 1 plus x. Okay, bakit ko nasabi na si 1 plus x yung nag-satisfy? Kay a is equal to 2. Kasi di ba siya lang man yung may equal dito. Kung sa condition 1 class, tingnan ninyo sa mga function ninyo kung saan yung may equal sign. May equal sa baba ng inequality natin. Tapos, yun yung pipiliin ninyo na function para sa condition 1. Okay, tingnan nyo din kung nag-satisfy sa a natin na value ng a natin. So, since a is equal to 2, which means dito siya nag-satisfy. X is less than or equal to 2. So, we have f of x is equal to 1 plus x. Hindi ko ginamit si 2 minus x because x greater than 2. Wala mang equal, di ba? So, f of a is equal to f of 2 is equal to 1 plus 2 is equal to 3. So, hence, f of a is equal to f of 2 equals to 3. Does exist. Okay? Okay, yung condition 1. So, let's proceed to condition 2. Thus, this is condition 2. Okay, this is condition 2. Thus, limit of f of x as x approaches a exists. Okay, so tingnan natin if yung two-sided limit ba natin is mag-exist siya. So we need to consider the right hand and the left hand limit to be able to find out if the two-sided limit f of x as x approaches a exists. So we have, for the right hand limit class, we use the function f of x is equal to 2 minus x. Bakit natin ginamit si 2 minus x? Why not 1 plus x? Because siya yung may positive infinity, or ito yung function na approaches to positive infinity. Kasi right hand limit man. Right hand, which means approaches to positive infinity. Since it is the only function in our given that approaches to the right of a is equal to 2. So the limit of f of x as x approaches a to the right, so nalagyan ito ng a to the right is equal to the limit of 2 minus x. Okay, ito yung pangalawang function. Take note, pag right hand limit, ilayan yung andin na positive infinity ron. Okay? As x approaches to the right. So do not forget to put exponent na positive sa yung mabubasta right hand limit ay pag-evaluate yung ka para matitando right hand limits kanyan. Okay, so 2, substitute 2 here. So 2 minus 2, that is equal to 0. So ito yung right hand limit natin. For the left hand limit naman, we use the function f of x is equal to 1 plus x, since it is the only function in our given that approaches from the left of a. So di ba ito lang naman yung function na approaches from the left of 2, which means yung may negative infinity. Okay, katando yung mabuhay left hand limit pag-usar niya function sa left hand limit na suad na negative infinity ron class. Okay, so we have the limit of f of x as x approaches from the left of a is equal to the limit of 1 plus x as x approaches 2 from the left is equal to 1 plus 2 is equal to 3. Okay, since the limit of the right hand and the left hand are not equal, di ba? 0 is not equal to 3, then we can say that the two-sided limit f of x as x approaches a does not exist. So which means nag-fail yung condition 2. Therefore, mag-jump na tayo sa conclusion. Therefore, f is discontinuous at x is equal to 2 and it is this essential discontinuity. Di ba ang sabi man doon sa reminders? If condition 2 fails to hold and then the discontinuity is an essential discontinuity. Okay, so sa pagsagot ninyo ng mga exercises, pwedeng you have to follow my solutions para hindi kayo mawala. The function g, for the last example sa continuity of function, the function g defined by g of x is equal to 3x plus 5, where x is less than or equal to negative 2. And then the second function is 2x squared minus 9. X is greater than negative 2 at x is equal to negative 2. So, ang a natin dito class is equal to negative 2. Ang sa first function class is, ang x natin dyan is from negative infinity to negative 2. And then, yung sa second function naman natin class, kailangan nating i-transform para madali nating malaman kung ano yung gagamitin natin sa right hand or sa left hand limit. So, eto, since greater than, so which means it is from negative 2 to positive infinity. So, kung may positive infinity, which means yan yung gagamitin sa right hand limit. And then, kung may negative infinity, yan yung function na gagamitin for the left-hand limit. Kasi class, kapag ang given na function is ganito, 2 or more functions na siya, kailangan talaga natin i-apply yung right-hand and the left-hand limit. Okay, and then take note, ang gagamitin nyo din na function for the condition 1 is yung may equal sa baba ng inequality natin. Okay, pero tingnan nyo din kung equal siya doon sa A. Okay, since sa condition 1, thus g of a exists, since a is equal to negative 2, and the function g that satisfies the given a is equal to negative 2 is the function g of x equals to 3x plus 5. Diba si 3x plus 5 lang man yung may function na, yung function na may equal dito. Okay, so, g of a, this is not f. This is g of a, kasi g yung ginamit natin na function. G of a is equal to g of negative 2. Substitute natin si negative 2 kay 3x plus 5. So, we obtain negative 1. So, hence, g of a is equal to negative 1 does exist. Okay, so, nag-satisfy condition 1. For the condition 2 naman, thus the limit of g of x as x approaches a exists, we need to consider the right-hand limit and the left-hand limit to be able to find out if the two-sided limit g of x as x approaches a exists. So we have, for the right-hand limit class, we use the function g of x is equal to 2x squared minus 9 since it is the only function in our given that approaches to the right. So, di ba, eto lang man yung may positive infinity sa dalawang function na yan. So, limit of g of x as x approaches a to the right, do not forget to put a positive to the exponent of a as x approaches to negative 2. Saan ko ito kinuha? Doon, kasi yan yung given natin na a. 2x squared minus 9 is equal to 2 times negative 2 squared. Minus 9 is equal to negative 1. So, ito yung limit ng right-hand limit natin. And then, for the left-hand limit naman, we use the function g of x is equal to 3x plus 5 since it is the only function in our given that approaches from the left of a is equal to negative 2. So, we have limit of g of x as x approaches from the left of a is equal to the limit of 3x plus 5 as x approaches negative 2 from the left, which is equal to negative 1. Since the limit of the right hand and the left are equal, that is, the right hand kasi yung symbol na may positive, then left hand, that is equal to negative 1. So, moreover, if the right hand and the left hand limit are equal, and both exist, then we can say that the two-sided limit also exists. Right hand, left hand is equal siya sa two-sided limit, which is equal to -1. Thus, the two-sided limit does exist. So, nag-satisfy din yung condition 2. So, we can proceed to the condition 3. Is the limit of g of x is equal to g of a as x approaches a. From condition 1 and 2, we can say that the limit of the g of x as x approaches a is equal to g of a. So, tama, di ba? Kasi yung nakuha natin na limit sa second condition is -1. The same with the condition 1, -1 din yung nakuha natin na limit. Since we obtain g of a is equal to g of -2, which is equal to -1, and g of x, limit of g of x as x approaches a is -1. So, therefore, f is continuous at x is equal to -2. So, that is for the limits and continuity of function. Good luck for the next topic.